This video is going to talk about unit rates. A rate is a comparison of two quantities in different units. For example, if we say 3 apples cost 50 cents, 3 apples is the unit that you're getting. You're getting 3 apples, and 50 cents is the other unit. That's the unit that you're paying. Both of those, even though they can't really compare, it's like comparing apples to oranges, except it's apples to cents. They are two different things, and they are labeled with their unit of apples and cents. Let's go ahead and identify the units being compared in the following rates. Take a minute, pause, and try to figure out what are the units that are being used in these. We'll come back and we'll talk about it. Welcome back. So the first unit being compared in the first one are pairs. Pairs are being compared, and it's pairs to dollars. So we're comparing 5 pairs to $2. $1 for 3 kiwis. Dollars to kiwis. 4 tickets costing $7 is comparing tickets to dollars. 1 kiwi costing 35 cents is comparing kiwis to cents. Sally driving at 50 kilometers per hour is comparing the kilometers she drives to the number of hours that she drives. On a map, 1 centimeter represents 3 meters. We're talking about comparing centimeters to meters. A student earning $6 an hour for babysitting. Dollars to hours, or hours that she or he babysat. The recipe calling for 1 cup of flour for every teaspoon of salt. The actual units here, 1 cup of flour. Not just 1 cup, because you want to know what the cup is of, and every teaspoon of salt. So teaspoons of salt. Cups is the unit being used for flour, but you want to be careful to specify in there. We also have teaspoons for the salt. 1 of these quantities in a unit rate is always equal to 1. So a rate can be anything. Like back here, we had 5 to 2, 4 to 7. If we look at the unit rate, that's comparing it to 1 of something. So we're going to identify the quantity that makes these a unit rate. 1 kilogram of rice per 8 cups of water. The thing that makes this a unit rate here is there's 1 kilogram to cup of water. See how that 1 makes it a unit rate? Go ahead, take 10, 20 seconds, and find what makes the rest of these a unit rate. And when you come back, we'll talk about it. Welcome back. So the 1 apple costing 30 cents, we have 1 apple costing so many cents. So we know how much 1 apple costs. We know how much water 1 kilogram of rice needs. When we have $1 for 2 cans of juice, we have $1, and we know how much $1 will buy us. When we look at 1 can of juice costing 50 cents, am I recording? That'd be bad. Okay. When we look at 1 can of juice costing 50 cents, that 1 can is going to cost us 50 cents. When we look at the speed limit is 40 kilometers per hour, that means that for every 1 hour, we're going to go 40 kilometers. The hour is there. Every time we talk about miles per hour, that's talking about how many miles will we travel in 1 hour if we go exactly this speed and nothing stops us ever. Please don't try to drive like that. It's dangerous. Stop for stop signs and red lights and, pedestrians and all that stuff. She runs 1 kilometer in 15 minutes. We have our 1 kilometer, and it's going to take her 15 minutes to run that. Knowing a unit rate can help us to determine other rates. So if 1 book costs $3, we can figure out how much 2 books and 3 books and 4 books cost. So we have our 1 book equals $3. If we want to figure out how much 2 books cost, we're going to multiply the 1 times 2 and the 3 times 2. So 2 books will cost us $6. figure out how much 3 costs us, go back up to the unit rate. 1 times 3 is 3, so we're going to take that 3 times 3 to get 9. And then the same thing to figure out for 4 books. Multiply both sides times 4 to get 12. We could figure out how much 100 books will cost. Because if I multiply 1 times 100, I get 100. So I'd multiply 3 times 100 and get $300. Hooray! Unit rates. So they want us to complete the table for each rate. So if we know 1 book costs $4, we want to figure out how much 2 books costs. Well, to go from 1 to 2, I'm going to multiply by 2. So I'm going to do the same thing on the other side. And 4 times 2 is 8. So 2 books will cost $8. To figure out how much 3 books cost, I'm going to multiply by 3 on both sides because 1 times 3 is 3. And 4 times 3 is 12, which means that 3 books will cost us $12. 3 balls for each kid. So we've got 1 kid show up and you're like, okay, you're going to the batting cages, we'll throw you 3 pitches. We'll throw you 3 balls. Or you get 3 strikes, but that gets confusing because this says balls. So I want to figure out how many balls would I need if 4 kids shows up. Turns out this kid has friends. To go from 1 to 4, I'm going to multiply by 4. So to figure out how many balls I will need, I'll multiply 3 times 4, and 3 times 4 is 12. So I'd need 12. To figure out how many balls I would need for 9 kids, I'm going to multiply that 1 times 9, which means I'll also multiply that 3 times 9. 1 times 9 is 9. 3 times 9 is 27. So I would need 27 balls for 9 kids. If I get $5 of allowance per day, and I want to figure out, well, how much money am I going to make in the long run here? How much money will I make in the average school week? What about 5 days? Let's go ahead and multiply 1 times 5 to get 5. So then we do 5 times 5 to get $25 in 5 days. That's pretty good. It's a lot better than the way I wrote it, but whatever. Then we want to figure out how much will I make over 20 days? Well, how do I go from 1 to 20? 1 times 20 is 20. So then to figure out, it's 20. Then to figure out how much I would make, I would multiply 5 times 20. And if I'm not sure, I'll do my work down here. 5 times 0 is 0. 5 times 2 is 10. Wow, that would end up being $100. Woohoo! Then we've got Sherry. Sherry can walk 1 mile every 20 minutes. That sounds important. I'm going to underline it. 1 mile every 20 minutes. She can bike 1 mile every 5 minutes. Seems about right. Her school is 2 miles away from home. How much time can she save by riding her bike to school and back instead of walking? And then how far does Sherry travel altogether? So we have 2 questions here. How much time can she save if she rides her bike? And how far does Sherry travel altogether? Let's go ahead and let's take a look at both of these. The ratio table for walking. So to talk about walking, we're going to go ahead and look at the walking section. She can walk 1 mile every 20 minutes. So we're going to put 1 mile for 20 minutes. Great. But her school is 2 miles away. So I'm going to put a 2 under the miles, and now I want to know how long will it take her to walk that. So if she can walk 1 mile in 20 minutes, and I'm going to put another mile there, 1 times 2 is 2, so I'm going to multiply the time by 2 also. 20 times 2. I'm sorry. There's no undo, is there? Yes, there is. 20 times 2. 20 times 2 is 40, so it would take her 40 minutes to walk. But I also want to figure out how long would it take her to bike. So now I'm going to go back up here. So to bike, it would take her 1 mile, it would take her 5 minutes to go a mile. So 1 mile would only take her 5 minutes. She's still going 2 miles to school. So I want to figure out how long will that take her on a bike. Well, to go from 1 to 2, you'd multiply by 2. So I'm going to do the same thing on this side. 5 times 2 is 10. So it would only take her 10 minutes to ride a bike. Awesome. But the question was, how much time can she save by riding her bike? So let's take that 40 minutes that she would be walking. Anyways, it's only going to take her 10 minutes. So let's take that 10 minutes out. And that would save her 30 minutes. 30 minutes saved. That should say min. Not the point. 30 minutes saved. Hooray! How far does Sherry travel altogether? Well, that doesn't matter if she's riding or walking because she's going to the same place. She's just going to be taking different modes of transportation. So that's still going to be 2 miles. Unless, she tries to go back home. But we're not going to talk about that right now. How long does it take to walk to school and back? So for her to walk to school and back, now we're going to go ahead and do both of these. So now I want to know for 4 miles because it's 2 miles to school and then 2 miles back. So what we're going to do, 1 times 4 is 4. So 20 times 4 is 80, which tells me to walk to school and back is 80 minutes. Then they want to know how long would it take to bike. Okay, so to go 4 miles here, 1 times 4 is 4. 5 times 4 is 20. So it would take her, wrong way. It would take her 20 minutes to bike. How much time is saved if Sherry bikes instead of walks to work or to school and back? We're going to take that 80 minutes and figure out what's left after we take away the 20. We get 60. So she's going to save 1 hour. Hooray! All right, we're going to go ahead. You're going to work in the textbook next, and we are going to continue these slides on the next video. Have a wonderful day, kids.